Hi everyone, welcome to this presentation on multinomial Naive Bayes algorithm. First, we will try to understand how multinomial Naive Bayes algorithm actually works, and we will take some dummy data set to explain the working of multinomial Naive Bayes. But the focus of this presentation is going to be along with multinomial Naive Bayes and how it works. The focus is also going to be on out of core machine learning, how multinomial Naive Bayes can be a good choice for online machine learning model building and deployment. And in order to demonstrate that, I will be using sentiment analysis as a use case using IMDb dataset, which is essentially movies reviews. So what is multinomial naive Bayes? It's a variant of a naive Bayes algorithm and is particularly well suited for data which are categorical in nature. And we are picking up the data set like IMDb, which is a text data. And when we convert the text data into, let's say, some vector form, count vectors or hashing vectors, those are ideal candidates with naive Bayes algorithm. So it's actually well suited for tasks involving sentiment analysis, text classification using, some text data. The formulation for multinomial naive Bayes follows the same Bayes theorem where we are trying to predict the probability of a class, which is also called hypothesis in this case. Let's take a look at it, how we are going to compute the probability of a class given the input data, which is basically the prior probabilities. So we need to first focus on the prior probabilities here and also the class distribution. The denominator is simply a normalization factor. So let's take a dummy data set to understand how this Bayes theorem actually works. The first one is the probability of the class given the features. This is what we want to compute, or we want to know the hypothesis given the input data. How likely is that input data belonging to a class of 0 or 1? The probability of a features and a class, that means within a particular class, what are the probabilities of the words? We are talking about words here, since this is going to be IMDb data set, so the features are going to be words. And in other words, this is also called likelihood of the features. And then overall, the probability of the class, like probability of a spam class or not spam, depending on how many samples of spam we have and how many samples of not spam data. Probability of the features is simply a normalization factor. So this is what we will be using in this multinomial naive Bayes. Let's take some dummy data. So we have the email data like 1, 2, 3. They belong to a class of spam. 4 and 5 belong to class of not spam. The first step is to tokenize and find out the frequency of the tokens. So let's say the tokens are these. So like free, offer, shipping, limited time. These are the words from the input data for each of the class. So we're just going to compute the frequencies. The next step is to find out the class probability, which is quite easy. Probability of a spam, number of spam mails divided by the total number of records in the dataset. Probability of not spam, number of not spam emails divided by total number of samples. So we first compute the class probabilities. Next, we are going to compute the likelihood of each of the tokens in a known class. For example, let's say free, how many times free is present in the class of email belonging to spam. So we just count it and divide it by the total number of words in the spam class. And similarly, we are going to do that similar computation for all the tokens for that particular class. I have not done for all the tokens, the list will be pretty long, but the basic idea is to find out the likelihood based on how many times that token is present in each of the classes. So that defines the likelihood. Now we're going to compute the posterior probabilities, essentially the hypothesis that we are trying to find out. Let's say we have a new email, free offer on new products this weekend. Is it a spam or not spam? So we're going to use the class probabilities that we computed in the previous step and also the likelihood of the features that we computed in the previous step and use the Bayes formula to compute the hypothesis. So the likelihood of the entire email for each class. So let's say the probability of this particular sample, which is a new sample, whether it belongs to the spam here. So let's just take the tokens which are present in the sample here, and from the previous step, get all your probabilities and multiply all of them, and you get a value here. Likewise, we repeat the whole process for the other class. Now, these numbers may be wrong. I did not pay a lot of attention in terms of really making sure these numbers are right. So we repeat the same thing for the other class, and let's say this is the value. Here we have the probability of 0, and here we have something non-zero. Now, what we do is bring in the probability of each of the classes. So the probability that the hypothesis is spam for the given sample is equal to whatever we have computed in the previous step multiplied by the probability of the class, which is a spam class here. And likewise, we do it for the other class as well. So prediction is based on the maximum likelihood. And in this case, you have a value of 0 and non-zero. So the likely prediction is going to be not spam. That means this sentence or this email is not spam based on the uh, the computed probability or prior probabilities. And then the last step is prediction. Now we're going to use this multinomial naive Bayes formulation for incremental machine learning or out of core machine learning. That is the purpose here. But how is this algorithm really suited or suitable for out of core machine learning? The applications of multinomial naive Bayes is typically whenever we deal with discrete data or text data like spam detection or text classification or clustering the text data, so on and so forth. But how multinomial naive Bayes actually works or it is suitable for cases like out of core learning. Let's say our data set that we used earlier is the first data set. Just 1 second here. Yeah, so this is my first data set. And this is the new set that we have. So we have trained our multinomial naive Bayes using this data set. Now we are having new data and we will use this new data to incrementally update the probabilities in the model. without having to retrain the model right from beginning. So that's the purpose of out of core machine learning. So how is this possible? Let's take a look at it. We have the new emails like AI is great, ML and DL are products of AI. I have highlighted the word product because the product token existed in the previous data set. Now we will see with the new arrival, or rather one more instance of the same word, how the probabilities are going to be changed or updated. So likewise, in the previous case, in this also we're going to do tokenize and count the frequencies. So we have all these frequencies here. And notice the frequency for the word products is now 3 because we have the new mail which has the word product. Now these words are not in the previous set, so these are new words anyway. So compute the class probabilities, the spam and not spam, depending on how many new samples you have. So you're going to compute that. And after that, notice here the products, which was actually 2. Let me go back to the previous computation. So when we computed the product, that was 2 here. Look at the count was 2 in the previous data set. But now with the arrival of new data set, essentially the count is going to be 3. So now you notice here the product token is now 3 updated with the new email, and rest of the frequencies and the count remain the same. I've just highlighted one token so we understand the nuances or how the out of core learning is possible. Now with this new count, we are going to recompute the prior probabilities. Just like we did for the other tokens, we will do the same with the products as well. So the updated probability for the products is now 3 over whatever is the number of tokens in that particular class. So that got updated. Now when we have and likewise, you're going to do that for AI is great. What is the probability? And similarly for the other email also, we compute the class probabilities. So this is what, and then the predictions are pretty much the same base formula we will use here now with the updated computations. And that's how the out of core learning is possible with multinomial naive Bayes. I'm going to show you a Python example here with IMDb dataset, and I'll demonstrate how it's going to be working with multinomial naive Bayes. Okay, so let's take a look at the sentiment analysis using IMDb dataset. And we will use multinomial naive Bayes. Along with it, I'm going to simulate out of core learning. So that means what we will do is we will divide the data set into multiple parts, and with just one part, we will train the multinomial naive Bayes, and with the remaining other parts, we will incrementally train the same model without doing a complete new training of the model. So that's how the code is going to work. So this is IMDb dataset, and I'm going to use vectorization called hashing vectorizers. Dataset is available from Kaggle, and I have already cleaned the data or pre-processed the data, and I'll upload the data as well, where from where you can download. the cleaned data. I'm not going to be running this. This is a huge data set, and for training and running is going to take like 15 to 20 minutes. I've already executed it. I'm going to show you the output. So this is the clean data that I'm going to be using. Read it into a data frame. And this last column is the one that I'm going to be focusing on. Sentiment is the label, positive and negative, and they are equal in number, like 25,000 samples each for positive and negative. So this is fairly balanced data set. We will convert the label positive to 1 and negative to 0 numeric encoding, get all the text data into a variable, and now we are going to divide it into two parts here. So the training data would be 70% of the whole sample and 30% is my test data. Hashing vectorizer for vectorizing the data, multinomial naive Bayes, and accuracy score for tracking the accuracies. Here we're going to use the hashing vectorizer with alternate sign equals to false, means we do not want negative values from the hashing vectorizer. Initialize the multinomial naive Bayes, and we're going to have the batches of data here. Let's say each time we're going to use 100 samples, and those 100 samples will be incrementally training the model. Now we're going to run this in terms of a loop, and then first is transform the data into a vector. Partial fit is a mechanism that we are going to use here rather than regular fit. Partial fit means multinomial naive Bayes is going to use the incremental data to update the previously computed probabilities. So for that purpose, we'll use the function partial fit. And then we evaluate the test set. Now, in this case, we're using the same test set to evaluate. So what really is happening is, let me illustrate here what exactly is going on. So let's say you have 50,000 samples. I have divided into the test set. Test set is 10K, and the training set is, let's say, 40K. This 40K, I'm making a loop, and every time I'm taking 100 sample, and this sample is going to be training the multinomial naive Bayes, and this 10K I'm asking the model to evaluate all the time. So this loop continues. Now MNB has been trained with next time plus 100, 200 samples, and again I'm going to evaluate with the same test set, and after that loop will continue. Now multinomial naive Bayes has been trained with 300 samples, and so on and so forth. And you will see how the model progressively getting better. Let's take a look at the output here. So I've already done it here. So the batch 1 and total 350 batches. It started with 64% accuracy, and now slowly things are improving, as you notice here, 0.75, 0.77, and so on and so forth. So this has improved quite a bit. This also proves that out of code learning is indeed working with multinomial naive Bayes. Now, the last step that I have done is I'm putting all the data together, the train test split, and then hashing vectorizer multinomial naive Bayes. Now in one shot, I'm training with all the 70% data and then testing with the 30% remaining data, pretty much the same result you're getting. So that proves that the out of code learning is indeed working. I hope you enjoyed and liked this concept of out of code learning using a very simple naive Bayes algorithm. You can actually use this algorithm to set the baseline before you try something like a neural net or RNN or BERT or transformer and those complicated sequence-based models. Essentially, if you're getting 677% baseline accuracy with the advanced deep learning model, we should aim to get much better result. I hope you like this presentation. So that was the demo on multinomial naive Bayes, focusing on out of code learning using IMDb dataset. Thank you all for your time, and we'll see you in some other presentation